Okay, it's exam 2 for physics 102. Parallel plate capacitor is connected to a battery, has a charge of 10 coulombs. If the area of the plates is doubled, what happens to the charge? So C is kappa epsilon naught A over D. If I double the area, that doubles the capacitance. Since Q is equal to CV, it stays connected to the battery, so V is constant. If I double that, I double the charge. So it did have 10 coulombs, now it's going to have 20 coulombs. What must be done in order to uh, increase the amount of charge capacitor can hold? Well, C is given by this. So if I increase the area of the plates, that increases the capacitance. If I decrease the separation, that also. If I increase the dielectric, that increases the capacitance. So it is A. Storm cloud is above the surface of the Earth. There's the area of the cloud. So basically what I have is I have the cloud, I have the Earth in between it. It's separated by a certain distance. It's like a parallel plate capacitor. This is from your tutor assignment. What is the approximate capacitance? We assume that kappa equals 1. It's 8.85 times 10 to the minus 12 times the area, which is 1 times 10 to the 6 square meters, divided by the distance, which is 2 kilometers, so that's 2,000 meters. 4.4 times 10 to the minus 9, that's 4 nanofarads. What is the equivalent of this? Okay, well, the threes, that's 1 over a third plus a third plus a third. That's equal to 1. And then 1 and 2 is 3. So I have, this becomes 1. And then combine it with this one, it gives me 3 microfarads and 6 microfarads. And then the equivalent of that is 1 over a third plus a 6, which is equal to 2. So 2 is the right answer. For the previous circuit, what is the voltage across the 6 microfarad? All right, so I have 12 volts here across this 2 microfarad. That means I have 24 microcoulombs. So I have 24 microcoulombs here and 24 microcoulombs here. I'm looking for the voltage across the 6 microfarad capacitor. So I know that it has V is Q divided by C, or 24 divided by 6, which is 4 volts. So that is the answer. Or I could look at this and say, well, I have 12 volts here. I know that I have to have 8 volts and 4 volts here because of the way the voltages are distributed. So 4 volts is the answer to B for number 5. All 3 capacitors are identical, or all capacitors are identical. What is the voltage across C1? Okay, so you really have to think about how the voltages are distributed, because I have C and then I have 3C here. I have 12 volts here. I know I have the bigger voltage across this capacitance. The 2 voltages across these two will add up equal to 12, and one of them will be 3 times as big as the other one. And those numbers are only 9 volts and 3 volts. Notice how it fills all those requirements. So across C1 is A. What is the equivalent of this configuration? Okay, this was straight from your OpenStax. I have a 0.3 and a 12.5. And then when I do 1 over 0.3 plus 1 over 12.5, that's equal to 0.293. You know it has to be smaller than this one, so we can get rid of these two. And in fact, it's going to be pretty darn close to that one. All right. How many electrons pass through this material? So let's see, 32 volts at 2 ohms, so I is equal to V over R. That's 16 amps, and 16 amps, an amp is a coulomb per second times 10 seconds. That will give me Q. Q is equal to I times T, so that's 160 coulombs. But now I want to know, I want to know how many electrons. So 160 coulombs, there are 1.6 times 10 to the minus 19 coulombs per electron. And divide those two, and it gives me 1 times 10 to the 21. So number 8 is E. Which of these are possible units for current? Okay, not that one, not that one, not that one, but this is a possible unit. I is equal to V over R, volts over ohms, so 2 only. 9 is D. Which of these statements is necessarily true? The voltage across a voltmeter is very small. Not necessarily true. If you're measuring a large voltage, it'll be a large voltage. The voltage across an ammeter is small. That is necessarily true. The resistance of an ammeter is small, and a voltmeter should be connected in parallel. So I have 2, 3, and 4. Okay, suppose you apply several different voltages. This, by the way, was from your OpenStax. So I want to find the slope of this. The slope is 40 over 20. And that's equal to 2. So what I've plotted here is I versus V, and by Ohm's law that's equal to this, so my 1 over R is equal to 2, so R is equal to that value, which is D. Solar cell pushes 2 coulombs of charge in 8 seconds. What voltage does it provide? Well, first we need to find what is our I, that's Q divided by T. That's 2 over 8, or 0.25 amps. Now V is equal to I times R times 4 ohms. So the answer is C. Your house 2 light bulbs operate at 120. One has a power rating of 25, the other has a power rating of 100. Which has the bigger resistance? The bigger resistance is the one that will resist the flow of electricity the most. So the bigger resistance is the one that have fewer electrons going through it. So the bigger resistance is the one that will be dimmer. So A is the right answer. If there are other ways you can approach this, you can say P is equal to V squared over R. If R gets big, P goes down. So you can think of it in that way as well. What is the resistance of this heating coil? Well, just write this. P is equal to V squared over R. I have my voltage, my power. I just want to solve for resistance. So R is 120 squared over 1,000. Sorry about that. 14.4A. All right. Rank these according to the resistances. Well, R is equal to rho L over A. Rho is constant because it says they're made of the same material. Gosh, I'm very sorry. Later. So rho is just a constant because it's the same material. So let's just rank them. I'll just list them out. So I have F over R. I'm just going to have 1 over 1. F over 4 over the radius. So remember that the area is proportional to the radius squared. So I'm going to have a quarter over a half squared, which is a quarter. What I've done is I've taken this number 1 over 2 and I've squared it because the area is proportional to the radius squared. So you can see now actually that these two are identical, so you can jump right ahead and say that, well, D has to be the right answer. But let's go ahead and look at the others. I have 1 over 2, 1 over 4, 1 over 1 over 4, and 5 over 4. So rewriting those, 1, 1, 2, 4, and 1.25, or 1 1/4. And so ranking those, I have 1, 2 are the smallest, 5 is the next smallest, 3 is the next smallest, and then 4 is the biggest. What is the voltage of this battery? All right, let's first find its equivalent resistance. 6, 3, and 2. That's 1, 6 plus 2, 6 plus 3, 6. That's 6, 6. So that's equal to 1. This whole thing right here is equal to 1 ohm. So let's rewrite this a little bit. I have 4 ohms and 1 ohm, and I have some mystery voltage down here, but it tells me that R2 has a voltage of 8 volts. So if this has 8 volts, this also has 8 volts. So if I look at this, that tells me, well, I can think of it in a couple ways, that if this has 8 volts, this one, which is 4 times the resistance, has to have 32 volts. which would give me the answer, 32 plus 8 is 40. Well, let's think about it in a different way. That is that I is V over R, or that's 8 amps. So I have 8 amps through that resistor. I also have 8 amps here. 8 times 4 gives me 32. And then I say 32 plus 8 is 40. What is the equivalent resistance? So 3, 3, and 3. 1 over 3 plus 1 over 3 plus 1 over 3, that's equal to 1. And then I have in series with a 3 ohm resistor, so it's going to be 4 ohms. So this number 17 is A. Now the next one, what is the voltage across R5? So what is the voltage here? Well, if I have a 3 ohm and a 1 ohm with 12 volts, well, let's see, I think we've done this one. This one should be 9 volts, and this one should be 3 volts. Or I could say this is a 4 ohm resistor with 12 volt battery, so it has to have 3 amps of current. So I say 3 times 3 to give me 9, 3 times 1 to give me 3, doing I times R. Now, what am I looking for here? The voltage across R5. So R5 will have this voltage, 3 volts. So number 18, that's E. And then what is the current through R1? Well, R1 is this resistor. It has the total current, which we've already found is that value. So it's going to be B for number 19. Which of these resistors has the smallest current? Alright, so the current comes here, it splits in two. Going here and here, it splits evenly, and then it comes back. Come here, it splits up. I get two different currents. I get a big current, and I get a small current, because in the top branch, the equivalent, or yeah, the top branch has a bigger resistance to the flow of electricity. So the smallest current is C. Which of these equations is correct? Let's see, 10 plus 4I1, 10 should be minus 4I1. I1 plus I3 equals I2, should be I1 plus I2 equals I3. 4I1 plus 10, 4I1 should be minus 10. 2 plus 3I2, that's correct, it's positive because I'm going against the current. Minus 4, that's correct because I'm going from big to little side, so that's the right answer there. What is the direction and magnitude of I1? All right, I want to know this current. In order to find that, I'm going to use the big loop here. Let's just go in this direction. I get 10 minus 4I1 plus 4 equals 0. So that is 4I1 equals negative 14. So I1 equals negative 14 over 4. Negative 4, excuse me. So that's 7 halves. And so it's 7 halves to the left because it came out positive. 4 wires meet at a junction. The first wire carries 4 amps into the junction. The second carries 5 amps out of the junction. Third carries 2 amps out of the junction. And the fourth carries what? Well, let's see, I got 4 plus some unknown current is equal to 5 plus 2. That's just the junction. I know that this current has to go in. All right, so I then is 7 minus 4, or 3 amps into the junction. Circuit has 6 distinct currents. Which of these is an appropriate application of the junction rule? I2 plus I6 equals I5 plus I4. No, that's not correct. I4 plus I6 equals I3. Go back to this. This isn't correct because I2 and I6, I2 and I6, we could make it correct. It would have to have I1. It would have to be I2. Actually, no, it would just have to be I2 equals, I2 plus I5 equals I4, and that would make it correct. Just sort of several things wrong with that one. All right, I4 plus I6 equals I3. I4 is into it. I6 is out, so that's not correct. It should be I4 plus I3 equals I6. So I2 plus I6 equals I1. I2 is out and I6 is in, so that's not correct. It should be I2 equals I6 plus I1. So D must be the right answer. Let's just look. We're right here. I2 is in, I5 is in, I4 is out, so that is correct. Battery has this internal resistance. What is the usable terminal voltage? So remember, we have a battery. It has a certain voltage that comes off of the terminals, but it consists of a internal resistance and an ideal source of EMF. And so the voltage that comes off the battery is the combination of those two. It's going to be 10 volts, that's the EMF, minus I times R 3 times 2. So when you get a big internal resistance, you begin to lose your voltage of your power supply. All right, which of these for resistors in parallel is correct? The current going into must equal the sum of the individual currents in the branches. That's true. That's sort of the junction rule. Each resistor will have the same voltage. That's true for resistors in parallel. When resistors are in parallel, the equivalent resistance is always smaller than the smallest. That's also true, as we saw in a previous question. And Ohm's law applies to these resistors, so it looks like E is the right answer. And you have 3 resistors, 4, 6, and 12. What is the least equivalent you can get? Well, the least equivalent is going to be in parallel 4, 6, and 12 like that. I think that we've already done that one. But we know that it has to be less than 4, so we can get rid of that one at least. And then we do 1 over 4 plus 1 over 6 plus 1 over 12. That's equal to 3 over 12 plus 2 over 12 plus 1 over 12. That's 6 over 12, so that's 2 ohms. And what are you to Dr. Young? You are a student, but not just a student. I do get paid, but you're not just a paycheck for sure. You're definitely not an obstacle, though sometimes it might feel that way, but you're definitely not an obstacle. And indeed, as I've told y'all, y'all are excellent students, best students at Nichols, so I'm glad for that. All right, that's the end.